Hi guys. Well, we've been studying linear equations and some forms of linear equations such as the slope-intercept form and so on. You might wonder, what do people actually use these equations for? And we're going to look today at one of those things, which is linear modeling. So let's look. Section 2.5, using linear models. So we're going to have to learn some terminology, as we often do. Here's some vocabulary that you should learn, memorize. A scatter plot is just a graph that relates two sets of data by plotting the data as ordered pairs. So we've been looking at ordered pairs of just numbers that we just make up, but this data can come from the real world, and you can plot the data as ordered pairs on a graph. We call it a scatter plot because it's not going to actually be a line or anything. It's just going to be a bunch of dots on the plane. You'll just graph each point. Okay, so a correlation is the strength of the relationship between data sets. We'll look at that. Some examples. Trend line is a line that approximates the relationship between two variables or data sets of a scatter plot. You see, the points won't all be on a line by any means, but there'll be a line that approximates the data. A correlation coefficient, represented by the letter R, that indicates the strength of the correlation. Okay, so let's look at some examples. So if you have a scatter plot, it might look like one of these. And so as we go through, we have the first example is, I don't have everything plugged in here, excuse me. Get this going. Okay, sorry about that. So we have this one. It's called a strong negative correlation. It's strong because the points actually are pretty close to a line. It's negative because the slope of that line is negative. Okay, so let's look at the next one. So this one, if we did draw a line, it would have a negative slope, right? The line would sort of go through here like that. Okay, if we drew the line that fits it the best. So that would have a negative slope, but it's not the points aren't very close to that line. So we call it a weak correlation, but it's negative. Okay, this one on the other hand, if we drew a line, the points are close to it, that's why it's strong. Okay, so this one we say there's no correlation. There's really doesn't look like a line at all. I'll get rid of this. And then here we have, if we drew the line that fits this, it would look something like that. And so it's positive because the slope is positive, but it's a weak correlation because the points aren't that close to that line. And finally, we have one that we could draw a line something like that. And it's a strong correlation because the points are close to it. Actually, our line would probably go a little more like that, maybe. Points are close to it, and it's a positive slope, so strong positive correlation. So the strength of the correlation has to do with how close the points are to the line. Positive or negative has to do with the slope of the line. Okay? And that's what you have down here in the notes. Okay, let's see what else we have. This is important note. When graphing your data in a scatter plot, remember to label each axis. The independent variable is the x-axis. The dependent variable is the y-axis. Examples of independent variables are time, minutes, hours, years, etc. So that's oftentimes the x-axis will be time and the y-axis will be something that is measured over time. For example, the population of a certain town or county. So the x-axis could be years, okay, and so along here you have years on the x-axis, and the y-axis might be population. So if a certain town is decreasing in population as time goes on, and you plot the point for each year, and that's an example of a scatter plot. Okay. So here's an example. It says make a scatter plot of the data and describe the trend. So this data is just numbers. We don't really care what it stands for or what it means, but we're going to do this example. So, I don't want to show the answer yet. So we have plotted this data though. See, we have the points here. 1, 7. This is about 7 because the y-axis scale is 5, 10, and so on. And then we have 2, 11. That's this point. 3, 16, 4, 20, 5, 22. So we're asked to describe the trend. So the two things that we're going to say about the trend: is it strong or weak, and is it positive or negative? Okay, so think about that before I show the answer. See if you can decide, is it strong or weak first of all, and remember what that means, and is it positive or negative? So let's see what our notes say. Okay, as the x values increase, so does y. So that means it slopes positively, right? The slope is positive. And so we're told there's a strong positive correlation between the x and y values. It's strong because these are pretty close to on a line, right? So it's strong and the slope is positive, so it's positive. This note just reminds us how to graph an ordered pair, how to plot that point, and which we just talked about. 1, 7, go to the right 1, and on the x-axis then go up 7, 7 on the y-axis. So this point here, for example, is 1, 7. Okay. So now we're going to take this a step further. Use the data from example 1 to write an equation of the trend line and predict the y value when x is 10. So much for just saying it looks like a line. We can draw a line. We're actually going to write the equation of that line. So we can make an equation of a line if we have 2 points. Remember, we have a form of a line called the point-slope line, 2-point form of the line. Well, we start with 2 points. Let me back up. I was right the first time. Point-slope form. There is something called the 2-point form. We have not used that one. But we have the point-slope form, and we can find that if we just have a couple of points, because we can find the slope from those 2 points. So this is something that you've done, and we're going to see an example for this data. So what we do is we take a couple points that fall on that line of best fit. Okay, so we've plotted a line. Okay, here it is. And we just choose 2 points. And once you have those 2 points, you can write the equation of that line. So let's do it. First, find the slope. And you do that by the difference in the y's divided by the difference in the x's, right? Okay, so that's right there. And then that comes out to, y sub 2 minus y sub 1 is 16 is your y sub 2. 7 is your y sub 1, the y coordinate of the other point. X sub 2 minus x sub 1, that's the 3 minus 1. And that comes out to 9 over 2, or 4.5. So now we have the slope. Okay? So once we have the slope, we can use the point slope form like I just talked about. And here it is. Slope 4.5, remember. So the point slope form is this right here. Okay? We simply plug everything in. We'll use either point. Okay, so one of the points was 7, 1. Let's see. I'm sorry, 1, 7. One of the points was 1, 7. The other point was 3, 16. We're going to use the point 1, 7. So I'll write that in here. You can use either one. Okay, so we're going to take y minus y sub 1. So that's y minus 7 equals m times x minus x sub 1. That's x minus 1. And just to remind, that's x sub 1. That's y sub 1. Okay? So plug it in. Then distribute the 4.5 times x and 4.5 times minus 1. And then add 7 to both sides. And now we have it in slope-intercept form, which you might kind of gather that's our sort of go-to form. The point slope form is very useful to find that line, but we don't leave it in point slope form. We're going to convert it to slope-intercept form. Okay? Oh, ran out of room. Not very good. Slope intercept form. Okay, and that's essentially solving for y. Distribute, then add 7 to both sides, and you've got it. So now that is the equation of the trend line. All we needed was 2 points. We used those 2 points to find the slope, which was 4.5. Then we used one of those points to plug into this point slope form, then converted it to slope-intercept form. Okay. Okay, so now that we have that, we can make a prediction. And that's what we're doing right here. Because we wanted to predict, well, what is y going to be if x is 10? That was the other thing we wanted to do here. Predict the y value when x is 10. So now that we have an equation, we just plug that in for x. We plug in the 10. There it is. Plug it in for x in our equation. So, and then calculate it, and we say, well, if x is 10, y is going to be 47.5, and this will be our point. Okay? So there is no point. We do not have data when x is 10. Okay, that was not in our data set, right? Because here's our original data. Data from example 1, so it's way up here. There's no point when x is 10. But if we want to know, well, according to the way these points look, what if x were 10? What if we kept going, so we only go out to our biggest x value we have is 5. But what if we had an x value of 10, way out here somewhere? What do we think y would be? And so we've made a line. We've written the equation of that line by using a couple of those points. And then once we have that equation, we can say, yeah, if x was 10, we're going to predict what we think y would be. And that's what this is. Okay, so that's a little example, a little look at linear modeling. We'll look at another example tomorrow. That's all for now.